Hello! Today we continue solving problems on gas laws. Since this topic is necessarily included in all sorts of exams, in test tasks, it makes sense, of course, to learn how to solve such problems without any problems. So, we are offered two problems. The first problem, it reports that a certain gas had at the beginning of the volume in cubic centimeters at the temperature of the process in degrees Celsius. And during the process, the gas was compressed to 50 centimeters in cubic centimeters. At this pressure, the original pressure was 1 atmosphere. And we are asked in this case what would be the pressure under the condition that the volume of this gas became 50 centimeters in cubic centimeter. So let us recall that in order to solve such a problem, we need to determine what gas law this calculation is following. As we understand, in this case, since the temperature is mentioned once and it did not change during this process, we will consider the temperature in this case to be constant. And therefore no recalculation is needed with this value in Celsius, that is, no recalculation is required. For the conversion to Kelvin temperature, then we have only two quantities, volume and pressure. Then it is necessary to remember that we have the formula of the unified gas law, which looks as follows. P1 multiplied by B1 divided by T1, and we have the number of moles involved here as well, and it is P2 times B2, H2, and T2. But as we realize, the temperature remains constant, and in this case, we are not told that the number of moles has changed in any way. Then we say that H1 and H2 are obviously equal to each other. Then we can neglect these values, i.e. actually our denominator, and then the formula takes a simpler form. P1 multiplied by B1, P2 multiplied by B2. Now let us see what is unknown in this formula, the modified formula. The unknown is pressure 2, P2. Then let's transform the formula. It will be P1 times B1 and divided by B2. Now we have to do the numerical substitution, and then B1 is 200 centimeters cubed, P1 is 1 atmosphere. 1 atmosphere. The volume of which is a gas mixture of 50 centimeters cubic. And then by the calculation of the problem, we will reduce centimeters cubic accordingly. The answer will be in atmospheres well, and 250 we can reduce also by a whole number. And then we get in the answer 4 atmospheres will be the pressure under changed conditions. The pressure will certainly increase because the smaller the volume, the correspondingly greater is the pressure. There's a direct correlation. Right now, problem number 2. Now let's see what this task tells us. We know the mass of some gas 60.6 tenths in grams. We know the volume of this gas 30 liters. We know the temperature at which this measurement was made, 36 degrees Celsius, and we know the pressure, 122 kilopascals. What is being asked? They are asking us about the mass of our unknown gas. So as we understand it, in this case, we're going to have a different gas law at work, to be precise, the equation of state of an ideal gas. And it looks like this. P times V equals nRT. In order for us to need to find the paint mass, we have to convert this formula a little bit. It will be mass divided by the paint mass, because the mole number is this ratio multiplied by the gas constant and by the temperature. But let's see that in this case, we need the temperature to be in kelvins, and it's given in Celsius. So first of all, let's convert the temperature into degrees Kelvin. To do this, we're going to add in Celsius and we get the temperature in kelvins. Now we can convert our formula to find the paint mass, and the paint mass is at the bottom of the formula. So then, in order for us to calculate the paint mass, we convert the formula. To do this, we multiply the mass of our gas by the gas constant, by the temperature in kelvins, and divide by the pressure and by the volume. That's it. And now we need to do a numerical substitution. And then we do the substitution for this calculation in the units that are required. And please note, since the pressure is given in kilopascal, we need to take this fact into account for the gas universal constant. So we do the substitution. The mass of the problem is 60 grams multiplied by the gas constant. It's equal to 8 whole 314447. Let's take the units of measurement in parentheses. Let's multiply the liter by the kilopascal. Why do we need to take the kilopascal? Because we have the pressure given in kilopascal times the Kelvin minus the first power, and multiplied by a mole minus to the first power. These are the units for the gas constant. And temperature converted to kelvins, 309 kelvins. That's our numerator. Now we go to the denominator. In the denominator, we have 122 a kilopascal. And multiply by respectively the volume, and we have a volume of 30 liters. Let's test whether we are correct using the units of the universal constant, and accordingly we find the answer for the paint mass expressed in grams per mole. So let's take a look. We have the liter shrinking, right? As we say, shrinking. The kilopascal is shrinking, so the Kelvin is shrinking too. And it turns out that we will really have grams per mole in our units of measurement. Well, if we do a mathematical calculation, we get 42 integers. 54 hundredths, and that's grams divided by moles. Or I could write it down as follows: 4254 as it's usually written, grams times mole, minus the first power. Either way, our answer for the unknown gas is 42.54 hundredths. So the problem has been solved, and I would like to draw your attention to the fact that the first problem was using the combined gas law of Gay-Lussac, Boyle, Marriott, and Charles. But the second task was to calculate using the equation of state of an ideal gas, or the Mendeleev-Ley-Perron equations. I hope you understand how we solved the problems. Goodbye.